I want you to look at whatever device you're using to listen to this right now. I mean, literally look at it. The screen, the casing, the actual weight of it in your hand.
Yeah, actually grip it for a second.
Exactly. Grip it. It feels, well, incredibly solid, right?
Right. It has defined edges. It feels permanent.
Yeah, and if you set it down on a table, you have this absolute confidence that it will just sit there, totally unchanged, until you come back for it.
Which makes sense. I mean, that's how we navigate the world.
But what if the very concept of a solid object is a complete hallucination?
Oh, that's a big question.
It is. Because what if instead of static matter, that device and like the actual hand you're using to hold it is actually a blazing, chaotic fire, just constantly consuming and renewing itself from one microsecond to the next?
It's a terrifying thought, honestly.
And it gets weirder. What if the seemingly empty air between your face and that device is not an empty void, but a roaring, boiling ocean of invisible energy?
It is deeply unsettling when you start pulling on this thread, isn't it?
Oh, absolutely.
Because as a species, we are biologically and psychologically wired to perceive solidity. We need the ground to feel solid so we can walk.
Right.
We need our tools to feel permanent so we can use them. But when you look closely at the underlying mechanics of the universe, that comforting solidity just completely evaporates.
Completely vanishes.
Yeah.
And breaking down that illusion is exactly what we are setting out to do today. We have an absolutely mind-bending deep dive ahead of us.
We really do. The stack of sources for this one is massive.
Yeah, so we're looking at excerpts from a book called The Quantum and the Lotus. It's this incredible, sprawling dialogue between a Buddhist monk named Matthew Ricard and an astrophysicist named Trinh Xuan Thuan.
Such a fascinating conversation in that book.
It really is. And on top of that, we are dissecting lectures from theoretical physicist Carlo Rovelli. We're poring over some pretty dense philosophy papers on ancient Indian metaphysics, too.
Right, and we're wading waist deep into the math of quantum field theory.
Oh, yeah, the math gets wild. But our core mission here, the whole point of this deep dive, is to trace the astonishing convergence between two incredibly different ways of observing the world.
Two totally different paradigms.
Exactly. On one hand, we have the 2,500-year-old Buddhist concept of Anicca, which roughly translates to impermanence.
Right.
And on the other hand, we have the bleeding edge of modern quantum physics.
Which is wild because these two frameworks originated in entirely different eras.
Oh, completely.
And they use completely different tools. I mean, one relies on this deep introspective observation of the mind, and the other uses, particle accelerators and incredibly rigorous mathematics.
Yet they have both systematically dismantled the idea of a static, solid universe.
They really have.
Yeah.
Though I do want to set a crucial boundary for us as we start.
Okay, yeah, let's hear it.
We have to avoid the trap of saying science proves spirituality or forcing these two disciplines to say the exact same thing.
Right, we aren't doing pop science mysticism today.
Exactly. Physics is an empirical science. It uses math to predict the behavior of matter. Buddhism is a soteriological tradition, meaning its entire architecture is designed to alleviate human suffering through ethical conduct and mental training.
Two different goals.
Very different goals. But with that boundary established, the crossover is just undeniable.
It's staggering. Both paradigms demand that you stop viewing the universe as a collection of isolated, permanent things and start viewing it as an infinite network of relationships and processes.
Processes, right, not things.
Okay, let's unpack this.
Okay.
Because to really feel the impact of what modern physics is discovering right now, we first have to understand just how disruptive the Buddhist view of reality was when it hit the scene.
Oh, it was a massive shock to the system.
Because it wasn't just a gentle philosophical tweak, right? It was a total rebellion against the ultimate security blanket of its time.
It was a philosophical earthquake. If we look at the intellectual environment of ancient India around the 5th century BCE.
Setting the stage here.
Right. The dominant framework was found in the Upanishads. The thinkers of that era were looking around at a world filled with disease, changing seasons, death, and they were fundamentally searching for an anchor.
Something that wouldn't change.
Exactly. They posited that beneath the chaos of the changing world, there had to be a permanent foundation. So they defined two eternal constants.
Brahman and Atman, right?
Spot on. Brahman was the ultimate, unchanging cosmic reality, and the Atman was an eternal, indestructible soul or essence inside every single person.
I mean, I can completely understand the appeal of that.
Oh, totally.
The world might be falling apart around you, you might be aging, but deep down you have this indestructible core that never changes. It's comforting.
It is the ultimate psychological defense mechanism against mortality.
Yeah.
But then Siddhartha Gautama the Buddha arrives, examines this entire metaphysical structure, and just dismantles it.
With the concept of Anicca.
Yes. Linguistically, the Pali word Anicca means permanent or constant, and the prefix a negates it. So Anicca means non-permanent.
And this becomes the core formula of all his teachings, right? Sabbe Sankhara Anicca. All conditioned things are impermanent.
Everything. Not just the obvious things like mountains eroding or leaves falling. Literally everything.
The gods, your thoughts, your consciousness, and crucially, your soul.
Right. He was introducing the concept of subtle impermanence. The idea that at every infinitesimal fraction of a second, reality is undergoing a three-part process: arising, alteration, and dissolution.
So nothing remains identical to itself for 2 consecutive moments.
Never. The universe is flashing in and out of existence so quickly that it creates the illusion of continuity.
Okay, I have to pause you there because this is the exact point where my brain starts flashing warning lights.
I thought it might.
Yeah, because if literally everything is constantly dissolving and arising at a microscopic level, how am I the same person I was when I woke up this morning?
It's the classic pushback.
Right. Like, if I am not a permanent entity, how do I have memories? Who is responsible for the things I did yesterday if the me from yesterday has already dissolved?
It is the most natural objection in the world. And what I love about our sources is that they show us people have been wrestling with your exact question for millennia.
Really? So it's not just a modern skepticism?
Not at all. There is a fascinating historical text called the Milinda Panha, or the Questions of King Milinda. It dates back roughly 2,000 years.
Okay, what is it?
It records a debate between an Indo-Greek king named Milinda who, was raised in the Hellenistic Socratic tradition of logic.
So he's a very rational, logic-driven guy.
Highly logical. And he's debating a brilliant Buddhist sage named Nagasena.
And Melinda basically corners Nagasena with the same logic I just used.
Exactly. He demands to know if there is no permanent soul who commits a crime and who is punished for it.
Oh, that's a great way to frame it. The legal implications of impermanence.
Right. And Nagasena responds with what might be the most elegant analogy in Eastern philosophy: the metaphor of the flame.
Let's hear it.
He asks King Milinda to picture an oil lamp that is lit in the first watch of the night. It burns through the middle of the night and continues burning right up until dawn.
Okay, I'm picturing it.
Nagasena then asks a very simple question. Is the flame that burned in the first watch the exact same flame that burned in the third watch?
Well, the king is a logical guy, so he says no, obviously not.
Mm-hmm.
The oil is burning away, the wick is consumed, the air currents are different.
Right.
The physical material of the fire is completely different.
Exactly. But then Nagasena asks the trap question, so are there 3 completely different lamps with 3 completely disconnected fires?
Ah, and the king has to concede.
He has to. No, it is the same lamp, and the fire burns continuously in dependence upon the oil and the wick.
Wow.
This is the radical core of the Buddhist view of identity. The self is not a static, unchanging noun. It is a continuous, self-consuming, and renewing causal process.
We are verbs. We aren't things, we are happenings. The me recording this audio right now is caused by the me who woke up this morning, just like the flame at dawn is caused by the flame at midnight.
Exactly.
But there is zero permanent substance carrying over. It is purely a continuity of process.
And the implications of that are staggering. It means reality is entirely fluid.
But for thousands of years, Western science vehemently rejected this idea.
Oh, completely. The scientific revolution in the West, built on Newtonian mechanics, doubled down on permanence.
Yeah, Newtonian physics gave us a universe that was basically a giant grandfather clock.
A perfect machine.
The consensus for centuries was that if you zoomed in far enough on any piece of matter, you'd eventually find tiny, indestructible, solid little chunks of reality.
The ultimate building blocks.
Yeah, they were essentially microscopic billiard balls moving through an empty void, bouncing off each other in perfectly predictable ways.
It was a deeply deterministic worldview. I mean, Pierre-Simon Laplace famously argued that if an intellect knew the precise location and momentum of every single atom in the universe, it could perfectly calculate the entire past and the entire future.
Laplace's demon.
Exactly. The universe was made of nouns, and those nouns followed strict laws.
But in the 1920s, that classical framework didn't just crack, it completely shattered.
It fell apart.
And quantum mechanics entered the chat. Because when physicists finally developed the mathematical and experimental tools to actually look at those supposed billiard balls, subatomic particles like electrons, they found that they weren't solid objects at all.
Not even close. They behaved in ways that defied classical logic entirely.
Like superposition, right?
Right. Before a particle is measured, it doesn't have a specific location. It exists in a state of superposition, which means it exists as a wave of probabilities.
That's just a maybe.
A mathematical maybe. It only acts like a localized particle when it is forced to interact with something else, like a measuring device.
And this brings us to the theoretical physicist Carlo Rovelli, who is heavily featured in our stack of sources.
He is fantastic.
He champions an interpretation of quantum mechanics called relational quantum mechanics, and he takes this wave-particle weirdness to its absolute logical extreme.
He really pushes the boundary.
He argues that particles aren't the basic ingredients of the universe at all.
No, he describes particles as mere quantum excitations of a field. They are temporary, localized events.
Events. Verbs again?
Exactly. But Rovelli's most radical claim is about properties. He argues that physical variables, things like mass, velocity, or position, are not inherent to an object. They are entirely relational.
Okay, wait. I want to spend some time on this because it feels like a massive leap.
It takes a minute to wrap your head around.
Yeah, because in classical physics, if I have a rock floating in deep space, it has a mass of 1 kilogram. Doesn't matter if there's a planet nearby or not, the rock inherently possesses the property of mass. Are you saying Rovelli thinks that's wrong?
In the quantum realm, it is demonstrably wrong. An object possesses absolutely no properties in isolation.
None.
None. An electron doesn't have a position or a momentum on its own. It only gains a physical property when it interacts with another physical system.
So the property isn't baked into the electron.
No, the property does not belong to the electron. The property belongs to the interaction between the electron and the other system.
Okay, let me try an analogy. Think about rendering a 3D video game.
Okay, I like where this is going.
When your character is in a room, the game engine renders the lighting, the textures, the objects. But if your character leaves the room and doesn't look back, the game engine stops rendering that room to save processing power.
Right, it unloads the assets.
The room doesn't exist as a solid, high-resolution physical space when it isn't interacting with the player's camera. Rovelli is essentially saying reality itself operates like an aggressive rendering engine.
That is a phenomenal way to visualize it.
Without an interaction, an object is just a cloud of mathematical potential. The code is there, but the graphic hasn't loaded.
Exactly. Relational quantum mechanics argues that there is no absolute observer-independent state of any system. There is no underlying true reality existing in a void. Reality is constituted entirely by the network of interactions.
When you lay that out, the parallel to Buddhism is uncanny. That is the exact definition of the Buddhist concept of anatta, or non-self.
It maps perfectly. Anatta posits that what we call a self or an object has no independent, isolated identity.
None at all.
Buddhism breaks a human being down into 5 changing aggregates: form, feeling, perception, mental formations, and consciousness.
Right.
If you search through those aggregates, you will never find a fixed essence. Just as Rovelli's electron only gains properties through interaction, a human identity only exists dependently.
In relation to its environment, its history, its community.
Yes.
You literally cannot define the electron without looking at what it's bumping into, and you cannot define a person without looking at their context.
You can.
Both disciplines are screaming at us to stop searching for the solid, permanent building blocks of reality, because the building blocks don't exist. There is only the web.
There's only the web. Which brings us to the absolute centerpiece of our deep dive today.
Here we are.
If solid matter doesn't actually exist as independent objects, we have to look at the space between the objects.
The empty space.
Right. If you take a region of space and you suck out all the atoms, block all the light, and remove all the heat, if you create a perfect, absolute vacuum, what is left?
Well, the intuitive answer is nothing.
Right.
And this is where people constantly misinterpret the Buddhist concept of sunyata,
Oh, constantly.
which is usually translated into English as emptiness.
Yeah.
In the West, when we hear emptiness, we think of a dead void,
Yeah.
like a black hole of nothingness.
A lack of something.
Yeah. But our sources, particularly the dialogues with Mathieu Ricard, emphasize that this is a catastrophic misunderstanding of the term.
It is the most common philosophical trap when studying Madhyamaka Buddhism, which was championed by the 2nd century sage Nagarjuna.
Okay, so what did Nagarjuna mean by it?
Nagarjuna sunyata does not mean non-existence. It means that phenomena are empty of independent, inherent essence.
Empty of fixed identity.
Yes. Because things lack a rigid, fixed identity, they aren't locked into being one specific thing forever. Emptiness is actually a synonym for limitless potential.
No.
Because reality is empty of fixed form, it has the dynamic capacity to manifest as anything, depending on the conditions.
So it's less like a dark, empty room and more like a lump of perfectly pliable, unshaped clay.
That's a great way to put it.
The clay is empty of being a cup or a bowl, which is exactly why it has the potential to become a cup or a bowl.
Exactly. Now let's take that concept of dynamic potential and lay it over quantum field theory's description of the vacuum of space.
Let's do it.
Because the physics completely backs up the philosophy here. In modern physics, we no longer believe the vacuum is empty. Empty space is actually a boiling, roaring soup of quantum fields.
Okay, how does space boil? If we took out all the heat and all the particles, where's the action coming from?
It comes fundamentally from the Heisenberg uncertainty principle.
Okay.
Most people know this principle as the idea that you can't perfectly know a particle's position and its momentum at the same time.
Right. The more tightly you pin down where a particle is, the more wildly its momentum fluctuates.
Exactly. The act of measuring one variable destroys the certainty of the other.
Got it.
But we can apply that same mathematical principle to time and energy.
Oh, really?
Yes. You cannot have a physical system where you know the exact energy state over a precise, tiny interval of time. A field cannot sit at perfectly zero energy with zero fluctuation.
Right, it can't.
The math literally forbids it. Even if you cool space down to absolute 0 Kelvin, where all classical thermal movement stops, the underlying quantum fields are still vibrating.
That is insane.
This is called zero-point energy. The vacuum is vibrating with an immense, irreducible baseline of energy.
And this vibrating energy field manifests as virtual particles popping into and out of existence, right? Well, like they borrow energy from the vacuum for a trillionth of a second, flash into existence as a particle and an antiparticle, and then instantly annihilate each other, returning the energy to the vacuum. That's the visual, right?
Let's slow down here and apply some necessary friction to that idea.
Uh-oh. Did I fall into a pop science trap?
Just a little bit. We need to be very careful with the pop science language of popping in and out of existence.
Okay, correct me.
The physics sources we reviewed stress that we shouldn't take this imagery too literally. It's not like there are tiny microscopic firecrackers constantly exploding in empty space.
So it's not a literal strobe light of particles.
Not physically, no. Mathematically, the ground state of a quantum field, the vacuum state, is actually stationary. The virtual particles you're describing are technically mathematical tools used in Feynman diagrams.
Okay, so they're on paper.
Right. When physicists calculate how real particles interact, say, two electrons repelling each other, they have to account for the infinite number of ways that interaction could happen. The internal lines in their diagrams represent virtual particles.
Wait, if they're just math tools on a chalkboard, why do we call the vacuum a boiling soup? Are we just romanticizing an equation?
Not at all. We call it that because those mathematical fluctuations represent something profoundly real, the non-commutative nature of quantum operators.
Okay, you're going to have to explain what a non-commutative operator is.
Sure. Think about basic arithmetic. 3 times 4 equals 12.
Right.
4 times 3 also equals 12.
Yeah.
The order of operations doesn't matter. The numbers commute.
Right.
In quantum mechanics, the math used to describe physical observables like position or momentum does not commute.
Wait, so the order matters?
Heavily. If you measure property A and then property B, you get a fundamentally different reality than if you measured property B and then property A.
Oh, wow.
This inherent mathematical tension, this irreducible jitter in the fabric of the math itself, is what we visualize as virtual particles. The field is never truly at rest. It holds a state of highly complex, vibrating tension everywhere all at once.
But this tension isn't just theoretical, right? I mean, it has actual physical force in the real world.
Absolutely.
I'm thinking the Casimir effect, which is one of the most mind-blowing physics experiments I've ever read about.
Oh, the Casimir effect is the ultimate proof that the vacuum is not empty.
Let me see if I can break down the mechanics of this, and you tell me if I'm getting it right.
Go for it.
So if you take two completely uncharged, perfectly conducting metal plates, and you place them incredibly close together in a perfect vacuum, we are talking micrometers apart.
Right. Microscopic distance.
The plates will actually be pushed together by a mysterious force. And the reason they were pushed together is because of these vacuum fluctuations, right?
Yes. Walk us through the mechanism, though. How do virtual particles push solid metal plates.
Okay, so because the plates are so incredibly close together, only virtual particles with very small specific wavelengths can fit between them.
Right.
It's like strings on a guitar. You can only play certain notes based on the length of the string. You can't fit a long wave into a tiny gap.
Great.
But the space outside the plates doesn't have this restriction. So it contains the full, infinite spectrum of virtual particle wavelengths.
It has all the notes.
All the notes. Because there is more quantum activity on the outside of the plates than on the inside, it creates a literal pressure difference in the vacuum itself.
A quantum pressure differential.
The empty space outside the plates physically pushes them together.
That is a phenomenal explanation. Empty space exerts physical pressure on solid metal.
Which just sounds like magic.
It does, but it's measurable physics. There is also the Lamb shift, which was discovered in the 1940s.
What's that one?
Physicists noticed a tiny unexpected shift in the energy levels of an electron orbiting a hydrogen atom.
Okay.
It turned out that the electron was constantly interacting with the zero-point energy of the vacuum. The virtual particles were essentially jostling the electron, slightly altering its orbit.
So the vacuum is aggressively participating in the physical world.
Very aggressive, though.
It is holding everything together.
And honestly, understanding the deeply technical mathematical reality of this makes the parallel with Buddhism far stronger than the pop science version.
How so?
Because the quantum vacuum is not an empty stage where things happen. It is a dynamic, pulsating foundation from which all matter manifests as excitations.
Right. The forms arising out of the soup.
Yes. This perfectly mirrors the Buddhist ontology of the Dharmakaya and the Sambhogakara.
Oh, let's define those terms for the listener.
Okay, you take the lead on this one.
So in Buddhist thought, the Dharmakaya is the truth body. It is the unmanifested, infinite field of potentiality that transcends time and space.
It is emptiness itself.
Right, the unshaped clay. And the Sambhogakaya and the Nirmanakaya are the manifested forms. The distinct, observable phenomena that arise out of that potential.
The cups and bowls.
Exactly. Everything we see, touch, and experience is just a temporary manifestation arising from the unified field of the Dharmakaya.
The Heart Sutra famously states, form is emptiness, and emptiness is form.
I love that quote.
For 2,000 years, that was interpreted as beautiful, mystical poetry.
Right.
Today, a theoretical physicist can point to a particle and say, well, form, meaning the mass of this particle, is emptiness because it is merely a localized excitation of the underlying vacuum field.
Wow.
And emptiness, the vacuum field itself, is form because it possesses intrinsic zero-point energy that can manifest as mass.
So the physical and the metaphysical are using different vocabularies to describe the exact same architecture of reality.
The exact same architecture.
Okay, so if the baseline of reality is this interconnected, vibrating field of potential, then how do the manifestations, the forms, the particles, the people, actually interact with one another once they arise?
That brings us to another foundational Buddhist doctrine, dependent origination, or pratityasamutpada.
That's a mouthful.
It is, but the concept is profound. This is the realization that absolutely nothing exists in isolation. Everything is tied to a staggering matrix of causes and conditions.
The Zen monk Thich Nhat Hanh has a beautiful way of explaining this.
Oh, the paper metaphor.
Yes. He tells you to look deeply at a piece of paper. If you really look at it, you don't just see paper. You see the tree that was chopped down to make the wood pulp.
Right.
But to see the tree, you have to see the sunshine that fueled its photosynthesis. You have to see the cloud that provided the rain.
It keeps expanding.
It does. You have to see the logger who cut the tree and the wheat that made the bread the logger ate for breakfast. The piece of paper is made entirely of non-paper elements.
Non-paper elements. I love that phrasing.
And if you remove even one condition, if you remove the sunshine, the paper ceases to exist.
In the Buddhist framework, the universe is fundamentally holistic. You cannot isolate a single variable without ignoring the infinite web of connections that sustains it.
Right.
It is a philosophy of total, inescapable interdependence.
And when we look at quantum mechanics, we don't just find a philosophical parallel for interdependence, we find mathematical proof of it.
Mathematical and experimental proof.
I'm talking about quantum entanglement.
Yes. Entanglement was profoundly troubling to early physicists. Albert Einstein famously derided it as spooky action at a distance.
He hated it, didn't he?
He refused to believe the universe operated this way because it seemingly violated the speed of light. But decades later, experiments definitively proved Einstein wrong.
Okay, let's dig into how those experiments actually work, because just saying they proved it doesn't do justice to how bizarre this really is. We have to talk about a Lane aspect in the Bell tests.
We definitely do. The premise of entanglement is that when two particles interact in a certain way, their quantum states become inextricably linked.
Tied together.
Right. Let's say we have two entangled photons. If you measure the polarization of photon A, you instantly know the polarization of photon B.
Even if photon B is on the other side of the galaxy.
Exactly.
Okay, but the classic counterargument to this, the hidden variable theory, was the glove analogy.
Oh, right. Walk us through the gloves.
So if I take a pair of gloves, put them in two separate boxes, and mail one to you in London and one to me in New York, the moment I open my box and see a left glove, I instantly know you have the right glove.
Right.
Nothing spooky happened there. The gloves were always left and right. We just didn't know it until we opened the box.
It was predetermined.
Yeah. Einstein argued that particles were like gloves. They had hidden variables, predetermined states that we just couldn't see.
Which is a very reasonable assumption. But John Stuart Bell, a brilliant physicist, developed a mathematical theorem in the 1960s to test this, to see whether particles were acting like gloves or if they were genuinely undecided until the moment of measurement.
And Elaine Aspect actually built the experiment in 1982 to test Bell's math.
Right. Aspect used a source that emitted pairs of entangled photons in opposite directions. He sent these photons toward polarizing filters.
Okay.
Crucially, Aspect set up a mechanism that randomly switched the orientation of the filters while the photons were in mid-flight.
This is the genius part.
It really is.
By switching the filters at the absolute last nanosecond, he ensured that there was no physical way for the two measuring devices to communicate with each other before the photons hit them.
Right.
Even a signal traveling at the literal speed of light wouldn't be fast enough to tell detector B what detector A was doing.
And the results of Aspect's experiment and many more rigorous tests since then violated Bell's inequalities.
What does that mean in plain English?
It means that the particles were not like the gloves. They did not have predetermined states. Photon A genuinely decided its polarization at the exact moment of measurement.
Right.
And photon B instantaneously adopted the correlated state, regardless of the distance between them.
It is instantaneous.
Yeah.
Faster than light. Which implies that they aren't actually sending a signal to each other through space at all.
They aren't communicating. The experiment proves that the universe is fundamentally non-local. Yes, our classical concept of here and there is an illusion generated by our macro-level perspective. At the quantum level, the two entangled particles are not separate entities separated by space. They are a single indivisible system.
Wow.
Space itself does not fundamentally separate things.
But doesn't this run the risk of conflating two very different things? I want to push back on our core premise for a moment here.
Please do.
Because dependent origination is a philosophical framework used to cultivate compassion and understand human suffering.
Right.
Quantum entanglement is a highly fragile mathematical state that usually only occurs in highly controlled, sub-zero laboratory environments. Are we just hijacking a physics experiment to validate a spiritual metaphor?
That is the exact critique leveled by many rigorous scientists, and it is a danger the authors of our sources take very seriously.
Good, I'm glad they address it.
If we stand here and say quantum physics proves Buddhism, we are being intellectually lazy.
Yeah.
Conflating mathematical formalism with soteriological spiritual insights leads to toxic quantum mysticism.
Oh, like the kind of pop psychology that claims you can cure disease or manifest a sports car by vibrating your quantum brainwaves.
Exactly. It strips the rigor out of both disciplines.
It really does.
Yeah.
So how did the scholars in our sources handle it?
What they advocate instead is a principle called complementarity without conflation.
Complementarity without conflation. I like that.
We don't pretend a photon is the same thing as human consciousness, but we rigorously recognize that both of these frameworks completely shatter classical objectivism.
Okay, I see.
Whether you are solving for wave function collapse or meditating on the nature of ego, the reality you encounter insists that you view it as an unbroken web of relations. They are two different lenses focused on the exact same underlying geometry of existence.
That makes perfect sense. And that brings us to the most intimate and perhaps most challenging part of this entire web.
The observer.
The observer.
Us.
We have talked about the vacuum of space. We have talked about particles. But what role does the human mind play in this dynamic process?
Well, in the Newtonian universe, the observer is a passive witness.
Right.
Reality happens, and you just watch it through a pane of glass. But Quantum mechanics introduced something called the measurement problem.
We touched on this earlier when we talked about superposition.
Right.
A quantum system exists as a wave of infinite probabilities until it is measured. At the moment of measurement, the wave function collapses into a definite localized state.
The chameleon picks a color.
Exactly. The act of looking forces the chameleon to pick a color. This fundamentally implies that reality is participatory. You cannot separate the observer from the observed.
Physicists fiercely debate the mechanics of why this collapse happens.
Oh, I bet.
Some early pioneers, like Eugene Wigner, actually flirted with the idea that human consciousness itself causes the collapse.
Really? That sounds almost magical.
It does, which is why modern physics leans much more heavily toward a concept called environmental decoherence.
Can we unpack decoherence?
Mm-hmm.
Because that sounds like jargon, but I know it's crucial to understanding how the quantum world builds the macro world we live in.
Absolutely. Let's imagine our quantum particle in its state of superposition, acting like a wave of possibilities.
Okay.
For it to maintain that delicate quantum state, it has to be perfectly isolated.
Like in a vacuum.
Right. But the universe is crowded. Eventually, a stray photon from the cosmic microwave background or a molecule of air is going to bump into our particle.
It interacts with the environment.
Yes. And when it bumps into that stray photon, the two systems become entangled. The quantum information from our particle leaks into the environment. As it becomes hopelessly entangled with the environment, the delicate superposition breaks down, and the system rapidly decoheres into a classical, definite state.
So it isn't necessarily a human eyeball looking through a microscope that causes the collapse.
No.
It is the inevitable interaction with the dense, messy environment of the universe. The universe is constantly measuring itself, forcing itself into classical reality.
Precisely. But whether the collapse is caused by consciousness or decoherence, the ultimate philosophical takeaway remains identical. Interaction shapes reality.
The observer, or the measuring device, is inextricably woven into the system it is measuring.
Exactly. Now let's map this onto Buddhist epistemology.
Let's do it. The sources delve heavily into how Buddhism views human perception. They talk about samskara, which are our mental formations, and vijnana, which is our consciousness.
In Buddhist psychology, observation is never passive. The way you perceive the world is aggressively conditioned by your habits, your past traumas, your biases, and your intentions.
Your history shapes your vision.
Deeply. When a practitioner sits in deep meditation and observes their own mind, they begin to realize that they are not just watching a movie play out on a screen.
Right.
Their awareness is actively constructing their reality in real time.
Your mental formations act like a polarizing filter on a camera lens.
That's a perfect analogy.
The raw data of the universe hits your mind, but your samskara filters out certain wavelengths and highlights others, creating the specific reality you experience.
The boundary between the subject who is watching and the object being watched dissolves.
Just like the quantum boundary.
Yes. Just as the quantum physicist realizes they are part of the physical system they are measuring, the Buddhist meditator realizes they are generating the emotional reality they are experiencing.
Which begs the ultimate question here. Why does any of this matter to the listener?
Always the most important question.
Right. Why should you care about Anicca or zero-point energy or wave function collapse on a random Tuesday while you were stuck in traffic or folding laundry?
It matters because internalizing this worldview offers profound psychological relief.
How so?
Well, in the Buddhist tradition, the root cause of human suffering, which they term dukkha, is clinging.
We desperately try to hold on to things.
We cling to pleasant experiences, we furiously resist unpleasant ones, and most destructively, we try to force permanence onto a universe that is fundamentally mechanically designed to be in flux.
Right.
We want our youth, our relationships, our career status, and our ego identities to be solid, indestructible objects.
Think about trying to save a live-streamed video.
Okay.
A live stream is a continuous flow of data. It's a process. But human psychology wants to grab that stream, hit pause, and save it as a static JPEG image on our desktop.
Oh, that's incredibly accurate.
We try to freeze the process into a noun. And when the image inevitably degrades, or when we realize the live stream has moved on without us, we experience profound anxiety and suffering.
By deeply understanding the reality of Anicca, by looking at the quantum mechanics of the vacuum and realizing that even empty space is boiling with change, you can develop radical emotional resilience.
Yeah.
If you view yourself and your life as a dynamic relational field rather than a static object, you stop trying to freeze the JPEG.
You realize that your current anxieties, The rigid sense of identity you feel trapped by and the struggles you are facing are not permanent solid brick walls.
They're not.
They're just passing excitations in the field. They arose because of a specific set of causes and conditions, and as those conditions naturally change, those struggles will inevitably dissolve.
It allows you to meet change not with panic, but with presence. You become adaptable.
You stop fighting the stream?
You become deeply compassionate, too, because you realize that everyone you interact with is caught in the exact same web of dependent origination that you are.
Yeah.
They are just as fluid and just as capable of change as you are.
Let's pull back and look at the incredible territory we have covered today.
We've covered a lot.
We started in ancient India, dissecting a debate between a king and a sage about a flame burning through the night, which shattered the illusion of a permanent self.
Right.
We jumped to the 20th century, where quantum mechanics dissolved the idea of solid billiard ball atoms, revealing a universe built entirely on relational interactions.
A universe of verbs.
Exactly. We stared into the absolute vacuum of space and found a boiling, seething ocean of zero-point energy that beautifully mirrors the Buddhist concept of emptiness as infinite potential.
Emptiness is form.
We explored how entanglement and dependent origination prove that the universe is an unbroken, non-local web. And finally, we saw how embracing this constant, unyielding flux can liberate us from our own psychological suffering.
The ultimate synthesis of everything we've discussed is this. You do not live in a static place. You live inside an ongoing process.
It's beautiful.
Yeah.
And to leave you with one final mind-bending mystery to chew on as you go about your day.
Oh, this is my favorite part.
As we wrap up, I want to look at one of the biggest paradoxes highlighted in our physics sources, the cosmological constant problem.
It is the perfect cliffhanger to end on.
It really is.
We spent a significant amount of time detailing the quantum vacuum, that boiling ocean of zero-point energy.
Right.
Well, when theoretical physicists use the equations of quantum field theory to calculate the total amount of energy that should be contained in the vacuum of space, the math gives them an incredibly large number.
How large?
Basically, the math says vacuum energy should be infinitely dense.
But we can test that math against reality, right?
Yeah.
Astronomers can look at the actual observed expansion rate of the universe, which is driven by this vacuum energy, often referred to as dark energy.
Right. And when they measure the actual expansion of the universe, the observed value of the vacuum energy, it's tiny.
Tiny.
The mathematical theory overshoots the observed reality by a factor of 10 to the power of 120.
Let's try to conceptualize how spectacularly wrong that is. 10 to the power of 120 is a 1 followed by 120 zeros.
That's absurd.
To put that in perspective, there are only about 10 to the power of 80 atoms in the entire observable universe.
It is widely considered the most massive discrepancy, the most embarrassing error, and the single biggest unsolved mystery in all of fundamental physics.
That is wild.
It means that our understanding of the vacuum, the very foundation of reality, is missing a massive revolutionary puzzle piece.
So I want you to ponder this as you turn off this audio. If our deepest spiritual traditions and our most advanced mathematics both agree that the seemingly empty space all around us is teeming with invisible, interconnected potential. Wait, let me rephrase that without trailing off.
Yeah, go ahead.
If they both agree on this teeming potential, what exactly is hiding in that boiling ocean of energy that we still haven't discovered?
It's a question that could change everything.
It really could.
Mhm.
And the next time you look down at your phone or your hands, remember you aren't holding a solid object. You are holding a blazing fire.